In this video, we are going to solve two main important problem in mechanics, which is the first problem is have the arrangement like this, where MA and MB are tied with some kind of a string where MA is moving in a circular motion. While in the second problem, we are going to solve a famous problem named Canonical Pendulum problem, where the mass M is hanged with some kind of a string and it is moving in a circular motion with having some angular velocity omega, and then we have to find the relation between omega angular velocity and whatever the angle it is making this alpha. So first of all, let us just solve first problem and try to find what is the tension and acceleration. Well, first of all, how can we solve this problem? So we will first start with concept. Now since MA is moving in a circular motion, then we have to first apply what is the circular motion concept. First we will start with circular motion concept. Now concept number 2, we will look at MB. So what are the forces applying on MB? Forces on mass B. Then concept number 3, we are going to use constraint relation. Why constraint relation? Because you can see the arrangement, this MA and MB are tied with a string. It means that they are constrained to move in such kind of a motion, such kind of a have motion. Therefore we are going to apply this concept number 3, and with this following concept we are going to solve this problem, and let us see how can we do it. First concept is saying that we have to apply circular motion. So for mass MA we have to apply circular motion. Now since it is attached with a string, let us say we have tension T1. Okay, now what does this tension T1 saying? Because tension T1 is in this direction, in inward direction, therefore we have to first recall that what is, now since MA is moving in a circular motion, what is the acceleration for circular motion? Now it has two acceleration, one is in radial direction and another one is tangential direction. Let's say from here to here we have, let's say this is R, okay, and from here to here let us say we have Y. Okay, from this to this string we have this Y length. Okay, now AR can be written as R double dot minus R theta dot square R hat. It is a standard formula which we have already derived using polar coordinate system, R theta double dot square theta hat, isn't it? So it won't be square, so R theta double dot theta hat. So we have this acceleration in the following system. Now this is your tangential acceleration, and since this mass MA is moving in a horizontal table, therefore we don't have any force acting on tangential direction, therefore A theta is 0. Then we don't have to care about whatever happens in tangential motion. Now since this object is attached with a string and therefore it will have this radial component, means that along the tension it will have some acceleration. Therefore this acceleration in inward direction, this minus t is equal to MA R double dot minus R theta dot square. Minus t is equal to, we can write MA X double dot minus X theta dot square. Now you can say that since this object is moving in a circular motion, therefore this length should be fixed, and R double dot means that let us say this one is X, this X has to be gone to 0. But my dear friend, this is attached with this complete string, therefore it is always possible that it can extend or it can go to this section. Okay, so we are not fixed, we cannot say that it is fixed. Okay, so therefore this is the kind of a very interesting job. How can we solve it? So this is your first equation. Now second equation, we have to look for mass MB. Now if you are seeing the MB, there is a gravity is working in downward direction, therefore M times G, upper is your T, therefore we can write here like MB into G minus T is equal to MB into A. So let us say it has acceleration, suppose Y, and we can do double derivative of it. Let us say this has acceleration A, we don't have to care about it 2. But now here is a problem. How can we find X double dot? This led us to the concept number 3. using constant relation. What is this constant relation? This is saying that total length of the string L and the upper portion is x and this downward portion is y. Do the double derivative, which is actually leading us x double dot plus y double dot is equal to 0. This is saying us that x double dot is kind of minus of y double dot. Now if you see here, a very good relation like tension in upper portion and acceleration in upper portion is equal to tension in lower portion and acceleration in lower portion. T1 into x1, they have to be equal. Therefore T2 y double dot is saying us minus x double dot. So x cancel, and therefore it is saying us that these two will share the same tension, but they are in opposite direction. Therefore if this is in this direction, if T1 is in that direction, therefore T2 will be in the same direction, in that direction. They are equal and opposite. Therefore whatever we have done here, we have written T as a negative, it is already correct. If we have written here like this, MB minus T is equal to MBA, it is also correct. Now we have already used these relation 1, 2 and 3 to figure out what is my x and y. So let us then use very simple one. Let us use everything in our bucket. What we can write here, first of all, minus T is equal to MA. Now x double dot, here you can see here x double dot is minus of y double dot minus x theta dot square, and we have now another equation mb times g minus of t is equal to mb. Now this acceleration is nothing but y double dot, since a is your y double dot, because it is a vertical acceleration. What we can use here, mbg minus of t, we can write here instead of ma minus of y double dot minus x theta dot square is equal to mb y double dot. So this guy I can take this side, therefore we were left with mbg minus ma x theta dot square is equal to mb plus ma y double dot. So we have followed only mathematics, and similarly we can say that y double dot is nothing but mbg minus ma x theta dot squared over ma plus mb. So you see we have got an amazing result to find out how to find the acceleration of vertical. Now if we know what is the vertical acceleration, you see here, now from this the constant relation, this a is equal to minus of x, this one. So using this we can easily find what is the acceleration which is this ma will experience, but whatever they are equal and opposite. So this is the complete situation here, and we can find out from here how to find the tension for this force. Well, you can analyze so many things. This theta dot is nothing but omega. Okay, this is their angular velocity, and from there we have easily found what is the acceleration vertically of the system. And let us come to our canonical pendulum problem. Okay, this lecture is gonna be fast, therefore you can use this space because this is important, and these are the lectures for who have already done his classical mechanics, the mechanics part. Now they need some review, therefore this space has to be maintained in this situation. Now for an example, in this situation a mass m is hung, but this mass is actually moving in a circular motion, means that you have a hand and you are rotating this mass, and therefore this has made a circular orbit and which is having the velocity omega. We don't know what is the relation between omega and alpha. Now since this mass is again moving in a circular motion, we have to first concept apply circular motion concept. That is the one thing. Second concept, where in this mass is attached with the string, therefore tension will be like this in this in the center direction. And let us say the length of the string is L, therefore we have to decompose the forces, okay, and this will gonna do our job. How? Let us begin. Now T is this one, therefore what is the component, because M is mg here, it's the influence of gravity. Now this alpha, this is 90, this will be 90 minus alpha, okay, and this is whole group is making 90, therefore this guy will be alpha. So this one is T, therefore it will be T cos alpha, And similarly, this situation here we have t sine alpha. So this is something like this one, m into g. Now here we have t cos alpha, and it is moving in a circular motion, so inward it is t sine alpha. Now first concept, we have to apply circular motion concept. So concept 1, circular motion, it says that t sine alpha, it is applying in this direction, and therefore we can say it is m r omega square, because it is the circular motion, we have seen it. Now in this direction, it is both are in the same direction, therefore minus minus, and it can cancel out, therefore t sine alpha is m r omega square. But what is this m r omega? We have assumed that r is the circular radius. Okay, let us say this circular radius, but the thing is that we don't know what is r, so we have to relate it. So what we can solve here, like for an example, this is your alpha, this object is moving, and this is the radius of the circle. So we can apply sine alpha, this one is the length of the radius, sine alpha is r over l, therefore r is equal to l sine alpha. So we can simply apply here, r sine alpha is m, r is equal to l sine alpha omega square. So you see, we can cut it down, t is equal to ml omega square. Okay, it is fine, let's say it is 1, but we don't know still what is your t. Now we have this equation t cos alpha mg. Now there is no any vertical motion, so we don't have any vertical acceleration. So concept 2, it is applying that t cos alpha is equal to m times g. So t is equal to mg over cos alpha, mg over cos alpha, which is ml omega square. M is cancel, we can write here gl omega square is equal to cos alpha. So you see, we got some relation. G is your constant, L is the length, which is constant length of the string, omega is the circular frequency in which the particle is actually moving in a circular orbit. Okay, and cos alpha is whatever the angle it is making with the hinge point. Now how to analyze the relation? So now we are in the job of analyzing whatever the physics it is going to show us. So g over l omega square is equal to cos alpha. Now we are going to deal with pure mathematics. You see, cos alpha can have the maximum value of 1 and can have the minimum value of -1, but here we don't care about -1, so we say that the upper limit of cos alpha is your 1 and lower limit is 0, so it can have the two values 1 or 0. Therefore we know cos alpha is, we have g over l omega square, let's say it is 1 and greater than 0. So in what case this omega is always has to be equal to 0, therefore we can write here that 1 by omega square is less than l by g, because 1 by omega square is l over g. So if you can reverse it, we can write omega square is less than g by l, therefore omega has to be lesser than and equal to g by l. But the problem is when cos alpha is equal to 1, cos alpha is equal to 1 for alpha is equal to 0. And what is the meaning of alpha is equal to 0? Means that the angle which is actually making this one is overlapped, means alpha is equal to 0. So if object is in this situation and it will have again this it is spinning with the rate, the high spin is square root of g by l. Okay, so this is gonna be high spin. If the object is spinning with square root of g by l, this object gonna be spin very fast if alpha is equal to 0. Now what happens with, now here is another limit, g by l omega square, it has to be greater than equal to 0, but it has to be again greater than 0. Why? Because gl by omega square is equal to 0, at which case this will be equal to 0. There is only one case when omega tends to be infinity, means that if this object is spinning so fast, okay, so fast, which is completely nearly impossible, then what is gonna be happen? Now at what value of angle alpha the cos alpha will be 0? We know alpha is 90 degree. We shows that whenever you have hinged here, this object will come in this point and go to like this. So omega is, if your omega is so much bigger and bigger and bigger, so this whole system will go in this situation and it will do the circular thing here, okay, which is kind of a very impossible thing. So no matter what, this will not equal to 0, but it can be equal to L omega square, can be 0.0001 or so on. But if this motion is happening here, it is kind of a very much unstable. So the stable solution is, it can be maximum like square root of g by L and can be minimum of sum like this one. Okay, so this is the case of canonical pendulum. You can study more and more, but it was the recipe which has been already explained to you, how to find canonical pendulum motion, how to decompose forces, and how to analyze the circular motion problem without thinking too much thing. Just follow the mathematics and everything will be done. So if you have found this video interesting and the pace is good, then let me know. Or if you think that we have to lower our pace, then it is for another video we will gonna cover and talk about it later on. So thank you very much. This is Saddam Leonardo Kap signing out.